In fact, we managed lots of important customer platforms that needs to be always available, and they need to scale up regarding the scale size. In fact, we have lots of customers that needs multiple concurrent access, and we have to manage that in the best way. Because today everyone can use a public cloud hosting, but it costs a lot regards to the size of the single machine. So we started to implement this new technology, which is based on Kubernetes. And we changed the entire process from a monolithic approach based on vertical scaling to a new modern approach based on horizontal scaling. Of course, not all applications can be used in an horizontal scaling approach, but ILIAS is very good for this task. And we started from an actual implementation made by SR Solution in the Docker environment, and we enhanced that, adding the support for Kubernetes infrastructure, and we try to expand the code in order to support horizontal scaling. What are the most important key points about the horizontal scaling? The horizontal scaling has the ability to support variable loading instead of vertical scaling that has to be set as a prefixed size. And another point is the very short mean size scale that VM support. In fact, using the horizontal scaling approach, we don't need a huge virtual machine, but we need a very small one that can be, of course, increased during the entire process. And also, one of the most important requests that our customers made to us is the multi-zone availability. In fact, we work on public cloud and also on on-premise cloud that must be reachable from different zone and region, maybe. So we use Kubernetes as an orchestrator in order to deploy the entire environment on multi-zone and multi-region sites. And of course, the most important things about the horizontal scaling is that the entire procedure is supported by an orchestrator instead of the vertical scaling, which is always demanded to custom script written by us in order to manage the different virtual machine. This is an image that represents what horizontal scaling means. In fact, in the traditional approach, if we need more power and more performance, we scale, we stop the virtual machine, change the resource assigned to that, and then turn it on again. But this is an approach that makes down to the customer, and also it grow up our costs, because if we have a single machine that is not if we have a single machine that is not able to support the entire peak, we are not able to scale it up, and we have to turn it off and then turn it on again. In an horizontal scaling approach, we simply create more and more small size virtual machine and balance the peak across the nodes. This is very important also for the cost, because this is a simulation of 500 simultaneous peak connection scenario. For example, if we have a big customer that start at 9 a.m. with 500 employers that needs to log in inside the platform, we have a different use of resource. In fact, in our case, there's always a peak of access during the day, and maybe this peak dures 1 hour for day. In this approach, we have, in this chart, we have the two different approaches. The first one is the Kubernetes approach. In fact, here we manage the peak using 10 small virtual machines. And in the other approach, in the single instance approach, we have one very large instance that costs too much than the resource we need all the day. In fact, if we compare the cost, we have a single use cost for the single hour of 0.48 euro in a Kubernetes scale set. On the other hand, we have a very small, a smaller cost per hour for during the peak. But if we compare the normal cost of hour, we can notice that Kubernetes infrastructure is almost 10 times less than the single instance normal use cost of hour. So what does it mean? That means that during the peak we can scale up and optimize our cost. And during the normal usage of the platform, we don't have a very high cost. We simply have the cost of 3 small instances instead of one big instance. Of course, the main goal was to scale all part of ILIAS, because ILIAS is composed by a database and an application server. So we needed to scale not only the application server but also the database. And we analyzed the 2 different strategies and 2 different applications in order to reach this goal. The first one was PerconaDB, which is an open source implementation of MariaDB Galera. And the other service that we used to achieve this goal was RDS Aurora, which is a software as a service application made by AWS. What are the most important things in these 2 implementations? Use of Percona or RDS help us in order to have a distributed database with multi-master replication, because ILIAS, as well as lots of other web applications, doesn't have the possibility to set up 2 databases, one for read and one for write. So we need to use a solution that helps us to do that without changing the source code of ILIAS. Thanks to PerconaDB and RDS, we were able to set up a proxy SQL, which is a tool that parse requests based on the type of the request to the backend databases. So we have in this simulation 2 databases, one master for read and one master for write, and they can be replicated and scaled all over our region. Of course, Percona and RDS have some operator that can be interacted by Kubernetes in order to automate all the database management tasks like backup, scale, or replication. Which are the benefits of this approach? Of course, we have a benefit in terms of performance. In fact, we are able to use multiple databases at the same time and That means we have a better throughput and a better response from the platform. And of course, we have a bigger availability solution because the database is replicated in different zones of the same region, or maybe in different zones of different regions, and that can be useful to reach the multi-region disaster recovery. The other part, which Vincenzo worked on, is the system architecture. In fact, we find another point of limits about the scalability of ILIAS, and it was its storage system, because it's based on a file system, a local file system that can be, of course, as we do in our tests, shared using protocol like OCF S2 or NFS, but it doesn't consent now the possibility to be scaled everywhere and without lots of resources and with some limitation. So we analyzed the S3 protocol, and Vincenzo makes a plugin that helps us to use the protocol.
Thanks, Davide. And yeah, so we analyzed the S3 protocol because the normal local storage service isn't as much as our performance as well as S3, and it's not scalable. Yep. And so with the S3, we can enhance all the read and write processes of an ILIAS installation, and so that it can be scalable with Kubernetes. The main goal of the project was to implement, with ILIAS IRSS, but because of it's not everywhere implemented in ILIAS at this moment, we chose a different way to use S3. And one of other key points are the payment system, that is pay as you go, so that you can only pay for what you use and not all the file system. And so that the cost is very, very low compared to the normal storage. And it can be scalable to very large volumes. As Davide said before, we use ILIAS Docker by SR Solutions and enhanced it to work with Kubernetes. The integration with the S3, for this integration, we used an approach of via a cron job on ILIAS to periodically upload all the files, the media files, to an S3 installation on AWS in this case. And so when users go to a page of ILIAS which have many images, videos, all the media, the URL of these media files are not on the ILIAS server, but are on S3. So that the load is not only on the server, but it's scaled on S3, which guarantee the scalability.
Yes, thank you, Vincenzo. And another very important point about S3 is that S3 is a standard, is not only linked to AWS, but it can be implemented in every premise using a software like Sminio, and it allow us to reach flexibility and cross-region copy of the files. About the technical implementation, as I said before, we started from the ILIAS Docker released by SR Solutions, and we uses the Kubernetes persistent volume. So we mapped all files of the Docker container to a persistent volume, which is shared across the nodes, and permits us the ability to scale up or scale down, or evict or delete the single elements of the infrastructure called pods, thanks to the use of this persistent volume. In this simulation, we will show you a live test if the internet connection permits us to do that. We use NFS as shared storage, but we also used in our production environment OCFS2, which is a storage system by Oracle that allow us the share of file system volume. Of course, this is at the actual state, but as Vincenzo said, our goal was to replace the entire file system to a stateless file system like S3. And what are the result we achieved? Of course, the increased ability to handle workouts without performance degradation. And we also reached a significant reduction of costs. In fact, now we are able to plan the cost of infrastructure, and if our customer, for example, have a plan of a high demand of the infrastructure, we can simply set the ability to scale, and resize the ability to scale of the platform, and it can be just with one click. Okay. From my side, it's all, and we would like to show you a real test, if we are able to do that using the internet connection. In fact, we would like to simulate with you. I don't know if you are not showing my screen. Okay. Can you see? Okay. Okay. To do this test, we use Apache JMeter, which is a very powerful tool that allow me to simulate 500 access to the platform in a time of 120 seconds. And on the other side, I have Lens, which is a tool that allow me to interact and manage my Kubernetes cluster. Here is the actual situation without any load. In fact, we have a three pods replica, which allow us to be present in 3 different regions. In fact, every pod have its own region. And now we will start this task, and Kubernetes will start to analyze and react to the change in performance request. It should start. As you can see on the right, we are sending the request. The platform will be able to scale in pods terms. So it will add new pods in order to manage as you can see, the workload. And then when it will finish the space of the cluster, it will automatically request a new node, and so new space, new resources, new CPU, new RAM, and place the new containers inside the new node. It is done automatically without any needs, and it will scale down scale up and scale down when the resources are not required anymore. In fact, now we are managing 148 connection 4 times, and our infrastructure is scaling up to 20. We have set a limit of 25 pods. At the end of this simulation, we will have 25 items, which are pods that are able to manage the inbound connection. As you can see, we are now scaling, and we also are automatically adding nodes to our infrastructure. In fact, now we have 3 nodes. As you can see, they are full of RAM. So the infrastructure is automatically calling new nodes and new pods. And we are, at the same time, we are managing the connection without errors. In fact, all threads are done. In these threads, we do ILIAS login, and we ask for a repository page. And the most important thing is that the connection are not stopped and are not rejected by the infrastructure. Okay, now we have done the first scale, but the most important thing is that now the platform has been scaled to 16 items, and if I do another cycle of request, the time will be, of course, less than the time before, because we have a scaled infrastructure that is now able to support the entire load. Okay. I would like just to finish the simulation. As you can see, it is automatically scaling. Everything is green, so it's good. And it will again update the cluster state every 5 minutes. So if I don't do any traffic for 5 or 10 minutes based on the timeout we set, the infrastructure will scale down, saving cost, and removes the single instance we applied for this simulation. This is very important because in a real scenario, customers needs a support for the peak time and then slow down for the normal platform usage. Okay. It seems to work. Just okay. In the meantime, if you want Vincenzo to show the plugin we have done, we have created based on this picture.
Yes. So I will demonstrate now the second part of the project to integrate with the S3. So I will, sorry.
So salvato.
Non ho fatto salvare.
Session timeout.
In the meantime, do we have any questions?
It's a long password.
These pod instances, are they containing all of the system, or is these pods only PHP or web server?
They only contains PHP source code because they are linked using the persistent volume.
Yes, in the database?
The database is outside. In this case, we use RDS Aurora,
Yes.
which is powered by AWS. And in on-prem version of this scale, we use Percona.
Okay, you had the cost for the workers pods written down.
Okay.
In my experience, I/O performance for databases is really, really expensive in every cloud provider.
Yes.
So,
That's
how much of the complete volume is paid to the database resource?
It depends, because the new approach that AWS has using Aurora serverless is based on resource unit. So you pay only the scale of the database. You don't have to set a fixed resource assignment for the databases.
Are there any experiences is 50% for 50% of all the cost, 20% or 70%?
40% of the cost is databases. Yes. Every time, because you pay the service and they manage for you the scaling of the platform. For that, Percona is a very good instrument that we can use to manage by ourselves the database scaling set.
Is the service available in China too?
It depends. Sorry?
Give the microphone that the translator can hear you.
Oh, okay.
No?
I move.
If someone has a question, speak in this
Ah,
microphone.
okay.
please. Who has the question?
I would like to know, is this service available in China too? Because we have two instances for ILIAS, one for the rest of the world and one especially for China, due to the restrictions of the government.
It depends from your public cloud provider. In this case, I think that AWS have a region in China, and we can use that region. And of course, if we are inside the AWS environment, we can use the transit service from AWS in order to transfer data between the region without the China ban.
So it's independent of the cloud storage of the service provider.
Yes,
Okay.
it's independent.
Okay, thank you.
And even you can buy, for example, an Alibaba cloud, private
Okay.
cloud, and using Kubernetes you can set up, using application like Istio, set up a different regional cluster, one inside a banned country like China, and another outside. And thanks to the integration between the two clusters, you can share data without having performance issue.
Okay, thank you.
You are. I finished.
Okay. I will end this demonstration. This is just uploaded the image. So I can see the URL on a new page that is a standard ILIAS URL. But if I reload the page and the cron job uploaded it correctly, I refresh the page and now I should see that the image is on a AWS S3 signed link. So that when users load this page, they do not
Download that from the
server,
file system.
from ILIAS. So the load is less on the server and more on S3, which is scalable.
And another important thing is regards the security. Of course, we generate an API token in order to download the image based on the session of the user. So we are able to maintain and keep the end-to-end security about the file download. Okay? Okay.
Other questions?
Okay. Do you have a question?
Questions, but later because.
Yes.
Okay.
Thank you.
Thank you so much. In the meantime, it completed its scaling. If we can, you can see 25 items.
One for you, one for
Oh, yeah.
you.